So the rate of energy transport, from one place to another place per unit area is defined by Poynting vector. Okay, so it measures the electrical power. It measures the electrical power per unit area. Okay, so so today we shall discuss what. Look here. So right, the direction of the direction of Poynting vector, the direction of Poynting vector is the direction of Poynting vector is perpendicular to the plane containing the direction of Poynting vector is perpendicular to the plane containing both E and H, both E and H. So look here, are you writing?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
So this is the direction. You do this diagram. This is electric field vector. This is magnetic field vector or intensity. So this is the direction of the Poynting vector. So the direction of the P is perpendicular. This is perpendicular to the plane containing E and H. Okay. So this is the short question you have to remember. So this is the direction of the Poynting vector. You do this diagram. Okay. So as I told you, the Poynting vector measures the electrical power per unit area. So what will be the unit of the Poynting vector? What is the unit?
What?
Watt per
The
meter square.
unit of,
Watt per meter square.
Watt per
yes,
meter
very
square.
good. You have to remember. Okay. So unit is equal to, or I can say, you write like this. The magnitude of the Poynting vector is equal to power divided by area. This is the definition, third definition. Okay. So Poynting vector is equal to power by area. Okay. So its unit will be watt divided by meter square. Watt divided by meter square. Okay. What is the dimension? Next dimension. Sometimes the short question asks find the dimension. The dimension of the Poynting vector. Okay. So accordingly, if you do calculate, your dimension will be m1 L0 t minus 3 A0. A for ampere, not area here. Mass, length, time. This is your ampere. Okay.
Okay.
M1 L0 t minus 3 A0. Okay. So write one problem. We have to do one problem from this. Right. A laser beam of 60 watt source. Hurry up. A laser beam of 60 watt source is incident. A laser beam of 60 watt source is incident on a circular object of radius 7 micrometer. Find the magnitude of the Poynting vector. Find the magnitude of the Poynting vector. Okay. Find the magnitude of the Poynting vector. Fine. Pragya, are you there?
Yes, sir.
Pragya,
Yes,
read the
sir.
question. Yes, read the question. Again, don't waste our time. Please
A
read the question.
laser beam.
Uh,
ए 6 वाट सोर्स ऑफ से मझिरे
ले
टिके छाड़ा
हां कोन हिची
सर मझिरे टिके छाड़ी देइछि लिखि
कौन तमे कहीं सब पाठ पाठ सब छाड़ी दियो नहले कौन ये हैं जदि छाड़ी दे तो तुम पचारिया कथा किए लिखिछ ठीक से सुनीला
यस सर मैं लिख
Sir,
पढ़नु पढ़ कौन लिखछु
a laser beam
ऑफ हां
a laser beam of 60-watt source is incident on a circular object of radius 7 micrometer. Find the
yes
magnitude of the pointing vector.
okay so how we have to do बताओ
Pointing vector is magnitude of pointing
sir,
vector
power
is
by
power upon
area.
area. Power is given in 60 watt.
power by area very good so whenever numerical is there as 60 watt is there area so what will be the area here
Pi r square करके
Pi r
very
7
good
square. And 7 into 10
pi
to the
r
power
square
minus
look
6.
here so you read the question 7 into 10 to the power minus 6 very good so you have to determine so question is laser beam of 60 watt so watt means power is given so in this question power is equal to 60 watt watt is incident on a circular object of radius that means radius is given radius is equal to 7 micrometer so micrometer means you see we have to convert into meter so our nature loves symmetry we have to express either in one unit since watt is in SI so we have to convert micrometer into meter 1 micrometer is equal to 10 to the power minus 6 meter okay so we have to find the magnitude of the pointing vector as I said the magnitude of the pointing vector formula just I said you magnitude of the pointing vector this is magnitude part power divided by area power by area so power is how much 60 watt area
60 watt.
so here since the laser beam is incident on a circular object so we have to find the area of a circle what is the area of a circle pi r square
Pi r square.
r square so this is equal to 60 pi pi means you can take 3.141 directly I can write 3.141 so radius square 7 into 10 to the power minus 6 you square so now you do the calculation like a school children what are the information you can write here okay so 60 divided by this so that gives you the what so the answer will
Magnitude
be
of pointing vector.
magnitude of the pointing vector so it is approximately 3.89 into 10 to the power 11 so what will be the unit lastly you have to write watt
Watt per
divided
meter
by
square.
meter square otherwise half mark will be deducted if you don't mention the unit okay so after doing the calculation this will be 3.89 into 10 to the power 11 watt per meter square okay pragya understood lekhiela
yes sir
जोटे लिखि पारते पचारिबो ना साइलेंट है कि बसी जाउचे खाली समस्ते ऑनलाइन क्लास माने आमे लिंक रे जॉइन करिकि वी आर बिजी हमर अलगा काम रे
Sir,
हला
answer टा
सार
उतरे.
माने तांकर बकु हां
Sir, answer टा उतरे कोई.
सार माने तांकर बकुतिबे आमे हमर खाली अलगा काम रे फेसबुक ये सब बा अलगा कोन काम रे बिजी हला सार माने त सस्ता अछंती आ कोन करा जीवो power is equal pointing vector is equal to 3.89 into 10 to the power 8 watt per meter square की इंटरैक्शन करबा कोठी बुझी होनी किछि नाही पूरा आइडियली हम पिला माने एते ब्रिलियंट सब जे सब पूरा ब्रिलियंट स्टूडेंट्स 3.89 into 10 to the power 11 watt per meter square कि सार गोटे कोन पठौचंती व्हाट्सएप रे गोटे रिप्लाई दबा सेतिके भी तुमको मोडा सिखिया को पड़िबो सार गोटे जदि कोन गोटे मेसेज करूचंती बा गोटे किछि तुमको पठौचंती ता परे गोटे रिप्लाई nobody is giving the reply Hmm. Okay. So next, so these are the problems 2 mark question important. You remember the formula based question. Okay. So accordingly you do your. So next is a pointing theorem. Poynting. Pointing theorem. So this is pointing vector. This is pointing theorem. See, this pointing theorem is also known as work energy theorem. It is sometimes known as work energy theorem. Okay. Okay. So you have to remember the statement as per the new syllabus. No proof is required. Previously, proof was there. Okay. So actually, what happened? Pointing first done the derivation. Okay. Then from the derivation, he had given the conclusion. Okay. So that conclusion is known as your pointing theorem. Okay. So write the statement. So it is also known as work energy theorem. What is the statement? Right. Look. Look. The flow FLOW, the flow of total electromagnetic energy the flow of total electromagnetic energy कौन लिखिला
The flow
The
of
flow
Total
of
total
total
electromagnetic energy.
electromagnetic.
electromagnetic
flow
energy
of total
magnetic
electromagnetic energy the flow of total electromagnetic energy through a closed area through a closed area enclosed by a volume enclosed by a volume is equal to the sum of rate of decrease of electromagnetic energy density
The decrease of
rate of decrease of electromagnetic energy
okay, sir.
density and the work done by the electromagnetic field mathematically the surface integration p vector dot ds vector is equals volume integration del by del t UEM dv minus j
Sir,
vector
outre.
dot e vector into dv. So this statement is known as pointing theorem.
Sir, outre equation ଟା.
ମୁଁ ଲେଖିଛି ଦେଖେ
ଦେଖାଯାଉନି.
So right hand
କଣ
side
ଦେଖାଯାଉନି ବ୍ଲର ହେଇଛି କି
right hand side ଟା ଦେଖାଯାଉଛି।
ହଁ
ଖାଲି sir right hand side.
surface integration p vector dot ds vector is equal to minus this is volume integration already पढ़ा ହେଇଛି del by del t uem. What is uem?
Electromagnetic energy density.
Very good. Electromagnetic energy density into dv minus this is j. What is j? J for
Current density.
current density. J vector dot e into dv. Okay. So this statement is known as pointing theorem. So first pointing had done the derivation part, then he got this answer. Mathematically he got this. Then he gave the statement. Okay. Subhalakshmi, are you there?
Yes, sir.
You read the statement.
The flow of total electromagnetic energy to a closed area enclosed by
No. Hey, the flow, the flow of total electromagnetic energy through. I'm two कहଥିଲି. Electromagnetic energy through. हाँ, तापरे पढ़. Correction कर. Through a
closed area enclosed by a volume is equal to the sum of rate of decrease of electromagnetic energy and the work done by the
electromagnetic density. Electromagnetic energy density. ଶୁଣିବାର ଅସୁବିଧା ହେଉଛି ନା ଦେଖିବାର ଅସୁବିଧା ହେଉଛି? ମୁଁ କହୁଛି ଏଠି ଲେଖୁଛି ବି ଏଠି ଲେଖା ହେଇଛି electromagnetic energy density. ହେଲା କରେକ୍ସନ କର electromagnetic energy density ତାପରେ
and the work done by the electromagnetic field.
Okay. तापरे कौन लिखा ला? Mathematically और mathematically
surface factor equal to minus volume integration del by del t
UEM
UEM dv minus volume integration j vector dot e vector dv.
Okay, very good. So this statement is known as pointing theorem. Question asked, you have to write this. Okay. So that means your pointing said that, so when the electromagnetic wave propagates, okay, this is the electromagnetic wave propagates, okay, he said that the flow of total electromagnetic energy through a closed area. Okay, suppose the electromagnetic wave is propagating through a closed area and this area is bounded by a volume. This is the volume. Within the volume, the area is present through which the electromagnetic wave is propagating. He said that the total electromagnetic energy. So while the electromagnetic wave is propagating through a area, then what will happen? There will be a rate of decrease of electromagnetic energy density. So whatever the total electromagnetic energy, that will be decreased. So decrease means minus. Minus del by del t. Rate means d by dt or del by del t. This is rate of decrease. Decrease means minus electromagnetic energy density and the work done. This is the work done. Work done means, you know, work is equal to force dot displacement. So here force means, since the electromagnetic wave consists of charged particles, so it will produce the current density J dot E. So this is the work done. This is the rate of decrease of the electromagnetic energy density, and the left hand side gives you the total electromagnetic energy. Okay, the total electromagnetic energy P for pointing vector. Okay, so this is the statement. Understood? Understood?
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Or we can say the rate of decrease of total electromagnetic energy within a certain volume is equal to the rate of dissipation or loss of energy. Okay, and the rate of energy flowing out by the surface. Okay, so you remember this statement. The total electromagnetic energy is equal to rate of decrease of energy density and the work done by the electromagnetic field. Okay, so this is known as work energy theorem. Okay, so what are the significance? Next, write the significance. No proof is required. Significance. Significance. Number 1 point, right? This theorem explains conservation of energy. This theorem explains conservation of energy. Conservation of energy in electromagnetic field. Okay, it gives, next point, it gives the direction of energy flow. On which direction? The direction of energy flow. Number 3, it defines the equation of continuity. It defines the equation of continuity. It defines the equation of continuity, which is equation of continuity means here already I told you this is del vector dot p vector plus del by del t UEM is equal to 0. Okay, so these are the significance. Ruturaj Lenka. Ruturaj Lenka, are you there?
So last point.
Sir, last
Ruturaj, read the step significance. What you have written. The first point is
This
Last
theorem
point.
explains conservation of energy in electromagnetic field.
conservation of energy in electromagnetic field. You remember, sometimes this is called as, I told you, work energy theorem or energy conservation law. It is also known as, you note down, energy conservation law in electromagnetism. If MCQ question will ask, which theorem is known as energy
Sir,
conservation law? Energy conservation law in electromagnetism. So your answer will be, option will be Poynting theorem, Gauss divergence theorem, Stokes theorem, Green's theorem. So which one is correct?
Pointing
pointing
theorem.
Pointing
Poynting
theorem.
theorem. Yes, remember. The energy conservation law in electromagnetism. Okay. Ruturaj, second point. It gives the
Sir, it direction of energy flow.
energy flow. On which direction the electromagnetic energy flows? What is the third point? It
It
defines.
defines the equation of continuity.
What is the equation? What is that equation of continuity? You read del vector
Dot p vector
plus
plus del by dt into del by dt of electromagnetic UEM is equal to 0.
so this equation is known as equation of continuity. So what is P here? P stands for Ruturaj.
Pointing vector.
Very good. What is the UEM?
Electromagnetic energy density.
UEM, electromagnetic energy density. Okay, everybody completed this part? Pragya?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So next. So this is the one of the important theorem. Everybody, today you have to remember. Next, we are approaching to complete this module. Next, average value. Average value of Poynting vector. Give the heading average value of Poynting vector. What is the average value? We have to find the average value. Okay. So so directly you remember, you see we have P is equal to how much? P is equal to E cross H. If I take the magnitude, this is power by area. What is A cross B? A cross B is equal to AB sine theta. Okay? AB sine theta. What is theta between E and H? Who can say?
90.
90 degree.
90 degree.
90
What
degree.
is sine 90 degree? What is sine 90 degree?
1.
1. So we got, you see, we got one formula. If you multiply E with H, we can get the magnitude of the Poynting vector. So P is equal to E into H. Okay. So you know the electric field can be written as E0 sine omega t. Electric field can be expressed as peak value. This is peak value. E0 be the peak value. Similarly, H can be written as H0 sine omega t. So this implies if you take the average, this is the average. E0 H0 sine omega sine square omega t. If you multiply, this is sine square omega t. So the sine square omega t average is equal to 1 by 2. So this is E0 H0 divided by 2. This is another formula. Formula based numerical you have to remember. If E0 is given, H0 is given, what is the average value? This is E0 H0 by 2. E0 H0 are peak electric field and peak magnetic field. Remember, this is peak electric field. The average value of the sine square omega t is equal to 1 by 2. Okay. So this is one formula. Again, another formula is directly I want to write. Okay. So the average value of the Poynting vector is equal to E0 square by 2 E0 square by 2 into epsilon naught by mu naught under root, and another formula is H0 square by 2 mu naught by epsilon naught under root. Okay, this is the formula based question. Okay, you have to remember. Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Suppose E0, epsilon naught, mu naught, all are constant. Only peak electric field is given. You apply this formula. Don't expect that on your question epsilon 0, mu 0 will be given, because it is 8.85 into 10 to the power minus 12. This is 4 pi into 10 to the power minus 7. Okay. And this is H0 square. H0 be the peak electric field, peak magnetic field. This is mu naught divided by epsilon naught. So E0 be the peak electric field and H0 be the peak magnetic field intensity. Magnetic field intensity. So you have to remember the 3 square by 2 H0 square by 2. Okay. Okay. You see, don't require to find the mu 0 by epsilon 0. Already, who can say what is mu 0 by epsilon 0 under root? Who can say? What is mu 0 by epsilon 0 under root? That is Z0. Already we have taken Z0. Yes, very good. So directly you can multiply here into 376.6 with H0 square by 2. Because already it is known this value is equal to 376.6 ohm, which is known as Z0. Z0 be the wave impedance. Okay. So this is all about your average value of the Poynting vector. Okay. Next, the last part you write magnetic vector potential. Magnetic vector potential. So magnetic vector potential, you have to remember the symbol is A vector. Okay. So the magnetic vector potential, right? It is a vector field whose curl gives the magnetic field. It is a vector field. It is a vector field whose curl means del vector cross A vector. It is a vector field whose curl means del vector cross A vector gives the magnetic field. That means from the vector potential we are getting the magnetic field. So that vector field is known as vector potential. समझ में आया? Next, electric scalar potential. This is magnetic vector potential. This is electric scalar potential. Electric scalar potential means we can take the symbol as phi. Phi with the electric scalar potential. If a curl of a vector field is 0, if curl of a vector field is 0, then that vector field can be expressed as gradient of a scalar field. Gradient of a scalar field, which is known as electric scalar potential. If curl of a vector field is 0, if curl of a vector field is 0, then that vector field can be expressed as gradient of scalar field, which is known as electric scalar potential. Okay, which is known as
Yes, sir.
electric scalar potential. electric scalar potential. Okay. So this electric scalar potential means we can write E is equal to minus del phi. Look the beautiful concept. A with the vector potential, we are getting the magnetic vector potential. Phi with the scalar potential, we are getting electric scalar potential. E is equal to minus del phi. Here one question asks, write the electric field in terms of scalar potential and vector potential. Write the question. Write electric field in terms of scalar potential and vector potential.
In terms of
Write electric field in terms of scalar potential and vector potential. So your answer is E is equal to minus del phi minus del A by del T. Samya,
Yes, sir.
understood?
Yes, sir.
What is the question?
Write electric field in terms of scalar potential and vector potential.
That means we have to write electric field E in terms of scalar potential. What is your scalar potential? Phi is known as scalar potential. And which one is your vector potential? A is known as vector potential. A is known as your vector potential. So we have to write in terms of scalar potential means phi, vector potential means A. So E is equal to minus del phi minus del A by del T. Okay? समझ में आया?
yes sir.
Yes, sir.
So this is one of 2 mark question, remember. Okay? So electric field can be written in terms of scalar potential and vector potential. Okay? Acha, one thing I have forgotten to say, the unit of vector potential. So you can write here, what is the unit? Unit is equal to Tesla divided by meter. The unit of vector potential is Tesla by meter. And here, the unit of scalar potential is volt. The unit is volt. If question asks MCQ based question, what is the unit of electric scalar potential? What is your answer?
Volt.
What is the unit of magnetic vector potential?
Tesla
Tesla
by meter.
by meter.
Tesla per meter.
Tesla by meter. Okay. So this is all about. Goodbye to our module 4. I have completed it. Okay. So very soon, if today time permits or tomorrow, I shall send you the assignment. You have to write your assignment. As you know, assignment carries 50 marks. So there will be 2 assignment. Don't expect that I shall give you, that means there must be 10 questions or more than 10 questions. Okay. Accordingly, I shall, if I shall give you more and more assignment, accordingly, I shall take the average mark. Okay. Just 1 minute. Charge come ho gaya. Okay. 1 minute. I want to take your closed. Don't go away. Huh?
Okay, sir. Okay, sir.
रही जाए सब जाओ 10 मिनट सब जाओ One minute. Huh? Okay. Understood?
Yes, sir.
Okay. So this is all about our module 4. So next we shall start module 5. Module 5, that is quantum physics. QUANTUM, quantum physics. One minute. I want to send you another link. If it will be all of you give the heading. Dedi, quantum physics.
Yes, sir.
Hello.
Yes, sir.
अब एक
Yes, sir.
एक मिनट इन so if this link will deactivate, I shall send you another link in your in Kalam physics group. Okay, you have to join on that link. Okay, so we have 10 minutes now. Pragya,
Yes, sir.
read what statement you have written, magnetic vector potential.
It is a vector field whose curl gives the magnetic field.
So it is a vector field whose curl gives you the magnetic field. Okay. That means magnetic vector potential is a what? Is a vector field. If you take the curl, that curl gives you the magnetic field. Okay. So from the vector potential, we can find the magnetic field. Okay. So what is the unit?
Tesla
What is
by
the unit
meter.
of the Tesla by meter? Okay. So next, you read the electric scalar potential.
If curl of vector field is zero, then that vector field can be expressed as gradient of scalar field, which is known as electric scalar potential.
Electric scalar potential. Okay. So that means if curl of a vector, if a curl of a vector field is zero, if you take curl of a vector field is zero, then what will happen? That vector field can be expressed as gradient of a scalar field. Okay, gradient of a scalar field, which is known as, that scalar field is known as electric scalar potential. Okay. Okay. So, what is the unit of the electric scalar potential?
Volt.
Volt.
Okay. Okay. So now all of you see, I have sent you another link to your Kalam physics group. Okay. Hello. All of you check.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So if this link will be closed, then immediately you have to join through that link. So एक काम करो, वही लिंक पे ज्वाइन करो, ठीक है? Hello, everybody.
Okay, sir.
Okay, sir.
Yes,
Okay,
sir.
sir. Okay, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Hello, am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Hello, hello.
Yes, sir.
Again, sir.
Yes, sir.
Hello, hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Present, sir.
Yes, sir.
Sir.
Yes, sir.
अरे सुबुत ना नहीं
Again, sir. Subuji.
ସାର୍ ଶୁଭୁଛି ସାର୍
आप किसी कहूना कहेंगे
ଶୁଭୁଛି ସାର୍।
ସାର୍ ଇକୋ ହଉଛି
Sir, କହୁଛି।
ओके
ସାର୍ କହୁଥିଲୁ ଆପଣଙ୍କର କ'ଣ ଅଡ଼ିଓ ଖରାପ ଥାଏ?
Sir, Bunni. Tama.
କୁହ କ'ଣ ହେଲା
Auntie go.
our next
ପ୍ରେଜେଣ୍ଟ ପଢି ସାରିଲେଣି?
okay okay so quantum physics hello अरे सुबुत
ସାର୍
Yes, sir.
Yes, sir.
Yes, sir.
କ୍ଲିୟର ଆସୁଛି
Subuni ki, sir.
ସାର୍ ଶୁଭୁନି କିଛି ସାର୍ ଶୁଭୁନି
ଆସୁନି
Sir,
sir.
not audible, sir.
सर आपका वॉइस नहीं आ रहा है।
Sir, left he gale.
Yes, sir.
Yes, sir.
Join, sir.
hello
प्रेजेंट सर।
Yes, sir.
hello
यस सर
Yes, sir.
यस सर।
Yes, sir.
Yes, sir.
यस सर।
Yes, sir.
Yes, sir. Yes, sir.
हेलो
Yes, sir.
सर।
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes, sir.
सर यस।
hello hello
Yes, sir.
Yes,
यस
sir.
सर।
Yes, sir.
फोन में प्रॉब्लम्स हो गए।
यस सर।
भारत माता की
यस
जय।
सर। तेजस बहुत हो गए।
hello
यस सर।
प्रेजेंट प्लीज सर।
सर हेलो हेलो सर
सर आपका ईयरफोन खराब हो गया होगा।
सर माइक टेस्टिंग।
Hello.
hello hello
हेलो।
यस सर।
यस सर।
यस सर
यस सर।
hello hello
हेलो
Yes, sir.
यस सर।
यस सर
यस सर।
Yes, sir.
सर यस सर।
hello
हेलो।
हेलो
अब मेरे
सर गुड मॉर्निंग
एम आई
सर माइक
ऑडिबल?
टेस्टिंग 1 2 3
इनकलाब जिंदाबाद।
Sound check. Sound check.
सर व्हाट्सएप में ले लो अटेंडेंस।
Yes sir.
यस
Yes sir.
Yes, sir.
यस सर।
सर अटेंडेंस सर।
सर एक में म्यूट कर दीजिए, बहुत अच्छा है। सर एक में म्यूट कर दीजिए, दोनों में या अनम्यूट है।
सर सुना ही नहीं दे रहा है।
अनम्यूट करके रखिए।
Present sir. Present sir.
अरे absent पड़ीजिए बंधु।
सर को सुनाई नहीं दे रहा।
सर अटेंडेंस व्हाट्सएप नहीं जानते।
Hello.
सर आपका इको हो रहा है आवाज।
सर आज जितने भी बच्चे हैं हम स्क्रीनशॉट मार के भेज देंगे ग्रुप में, आप अटेंडेंस डाल दीजिएगा।
हाँ सर, हेलो सर।
हेलो सर।
Yes sir.
Yes sir.
प्रेजेंट सर, प्रेजेंट सर। यस सर।
सर एक भी है, दो भी है।
Present sir.
चैट बॉक्स पे सही।
क्या सर, सुनाई नहीं दे रहे सर।
सर आपका इको हो रहा है।
अरे इको कर रहे हैं।
सर क्या बोले?
सर एक्चुअली आपका सर दो कौन है?
यस सर, यस सर, यस सर।
सर कीजिए।
किसी सुबुनी सर, किसी सुबुनी।
5 हो गया।
कौन?
सर 3 हो गया।
Sir 68.
अरे भाई रुको जरा।
बड़ी तेज हो रहा है बेटा।
9 10 11
यस सर, यस सर।
12
यस सर, यस सर।
13 विप्लव 14 प्रमानंद